Hello and welcome to this video on numerical integration. So we are going to be considering the second example to explain Simpson's one-third rule. To watch the first video, do well to look at the description of this video and you will find a link to that amazing video. Now let's consider this question. It says, if the velocity v in kilometer per minute of a moth which starts from rest is given by v equals integral from 0 to t of 2x exponential x squared dx at a fixed interval of time t in minutes for the first 1.2 minutes. Without converting to any other unit, I compute the velocity for the first 1.2 minutes to two decimal places at t equals 0.2 minutes interval. If the time is now fixed at t equals 1.2 minutes, estimate the approximation of the distance covered for the first 1.2 minutes to two decimal places using Simpson's one-third rule. I approximate the value of g if the closed form solution of the distance covered is given by x equals 4.99 g. All right, so we are given this equation. V is equal to integral from 0 to t of 2x exponential x squared dx, and we are asked first to find the velocity without converting. Now if you take a look at that question, okay, the first question says compute the velocity for the first 1.2 minutes to two decimal places at t equals 0.2 minutes interval. So you've been given an interval. Your interval, okay, interval which is h, okay, the interval which is h is equal to 0.2, okay, minutes. Now we are not converting since the velocity is also expressed in kilometer per minute. Okay, the velocity is actually in kilometer per minute, so no need to convert. So no need to convert yet. So our interval h, or the width, is simply 0.2 minutes. Now the time given there, maximum time frame, which is the upper limit. So the lower limit a is equal to 0, the upper limit b is equal to t, and from the question the time given there is 1.2 minutes. That's the maximum time, so b is simply 1.2 minutes, okay, from the question. So the highest time t is simply 1.2 minutes, and of course it starts from 0 to 1.2 minutes. Now h is 0.2. How is h 0.2? You recall the formula for h. H is simply equal to b minus a all over n, where n simply means the number of intervals and h itself is the interval, okay, or the interval width. Now, so how do we know that h is 0.2? Already given in the question. So we need to now find n, which is how many times this is splitted to obtain the interval to be 0.2. So the limit is from 0 to t, and t is 1.2, which means the limit is from 0 to 1.2. So which means we're actually splitting from 0 to 1.2 using this interval of 0.2. So we start with the first x naught, just like we did in the previous video. So x naught is the very first limit, in this case 0. Now you find x1. X1 simply means add 0 to the interval, which is 0.2. So you have 0 plus 0.2, which actually gives us 0.2. Next you find next you find x2, which is x1 plus the interval, and x1 is 0.2 plus interval is 0.2. This simply gives you 0.4. Okay, next you find x3, okay, and x3 is going to now be x2 plus the interval. X3 is simply 0.4 plus interval is 0.2. This gives you 0.6. Next you find x4. Okay, we find x4. X4 becomes x3 plus x3 plus the interval, and x3 is 0.6 plus interval is 0.2. This simply gives us 0.8. Next we find x5. x5 becomes x4 plus the interval. X4 is 0.8 plus interval is 0.2. This simply gives us 1.0. Finally, we find x6. X6 becomes x5 plus interval, and x5 is 1.0 plus interval is 0.2. This gives us 1.2. So we end it here. So now let's find how many intervals do we have. From x0 to x1, this is the first interval. From x1 to x2, second interval. From x2 to x3, third interval. From x3 to x4, fourth interval. From x4 to x5, that's the fifth interval. From x5 to x6, that's the sixth interval. So this simply means that n is equal to 6. So you see that you cannot employ the Simpson's wanted rule if the number of interval is not 6. So as given already in the question, we're able to now derive the number of interval using the given interval from the question, and we had 6, and 6 is simply an even number, which means it's safe to use the Simpson's 1 all over 3 rule to solve this problem. But just to confirm as well, you can go ahead and plug in this value into the relationship for h. We said is equal to b minus a all over n, and b itself is the upper limit, which is 1.2. So b is 1.2 minus lower limit is 0 divided by n is 6. And if you do this, you're going to have h to be 0.2, which is the interval given to us in the question. Okay, so I've already written out the Simpson's wanted rule over here. Integral from a to b of function f of x dx is simply equal to h all over 3 multiplying f of x naught plus 4f of x1 plus 2f of x2 plus 4f of x3. We explained all of this in the first video. All you're doing is the very first function and the last function, you don't multiply with any value. So you have f of x naught and you have f of xn. They are not being multiplied by any value, but the intermediate function you start alternating from 4, so it becomes 4 2 4 2 and so on, depending on total number of functions that we have. So that simply means in this case now x naught here, which is 0, we are not multiplying by any value, and then x6, which is our last function, in this case 1.2, we are not multiplying the function by any value. Then in between we change from 4 to 4 to 4 and so on. So let's find first the value of the function at each of these points. Okay, so first we find f of x naught, not forgetting the function f of x is given in the question here as 2x exponential x squared. So our f of x is simply 2x exponential x squared. So this means f of x naught simply means in place of x, plug in a value as x naught, or plug in the value of x naught in the equation. Okay, so we have 2x exponential x squared. That becomes 2 times x itself is 0 multiplied. Okay, sorry about this. So f of x naught is simply 2 times 0 multiplied by exponential 0 all squared, and of course 2 times 0 is 0. 0 multiply everything here is 0, so f of x naught is equal to 0. Next we find f of x1. So this simply means in place of x in this equation, plug in a value of x1, and x1, we obtain x1 to be 0.2. So 2x exponential x squared becomes 2. In place of x, x is 0.2 multiplied by exponential x again is 0.2 all squared. So this is actually 2 times 0.2 simply gives us 0.4. Exponential 0.2 squared also gives us 0.04. So let's find this value and see. So we have 0.4 multiplied exponential 0.04. That gives us approximately 0.4163. Next, you have f of x2. So in place of x now, we are putting in the value of x2, and x2 is 0.4. So we have 2x, which is 2 times 0.4 multiplied by exponential 0.4 all squared. So this is going to be 2 times 0.4 gives us 0.8 exponential. Now let's find 0.4 squared. That gives us 0.16. So we have exponential 0.16. Let's obtain this value and see. So we have 0.8 times exponential 0.16. That simply gives us 0.9388. Okay. Now we find f of x3. We find f of x3. This is now going to be equal to 2 times x3. So you have 2 into x3 itself give us 0.6. So that becomes 2 into 0.6 multiplied by exponential 0.6 squared, right? So you have 0.6 all squared. So this is going to be 2 times 0.6 gives us 1.2. That gives us 1.2. So 1.2 exponential 0.6 squared gives us 0.36. So that gives us 0.36. So let's see what this gives us. 1.2 exponential 0.36. This gives us approximately 0.7200. Okay. So next we find f of x4. This is going to now be, so not forgetting we obtained x4 to be 0.8. So f of x4 becomes 2 times 0.8 exponential 0.8 all squared. So this is going to be equal to, so 2 times 0.8 simply gives us 1.6. So you have 1.6 exponential. Now we find 0.8 squared, that gives us 0.64. So exponential 0.64. So let's see what this gives us. 1.6 exponential 0.64. That gives us approximately 3.0344. Okay. Next we find f of x5. So this is going to be once again 2 times x5, and we obtained x5 earlier as 1.0. So you have 2 times 1.0 multiply exponential 1.0 all squared. This is going to be equal to 2 times 1.0 remains 2, exponential 1.0 squared remains 1. So this is going to now be, let's find 2 exponential 1. This gives us approximately 5.4366. Okay. So finally we find f of x6, and that's going to be 2 times x6, and we obtained x6 earlier. X6 was obtained as 1.2, so we find f of 1.2. So that is 2 times 1.2 exponential 1.2 all squared. So this is going to be equal to 2 times 1.2 gives us 2.4, approximately multiply exponential 1.2 squared. Okay, so 1.2 squared simply gives us 1.44. So you have exponential 1.44. So let's obtain this value and see. So 2.4 exponential 1.44. This simply gives us 10.1297, approximately 10.1297, and you have this. So now we plug these results into the Simpson's rule. Let's fall back to the Simpson's rule once again. So as can be seen from the rule, we know what our h is, which is the interval, and the only thing we are doing is the first function f of x naught, we are not multiplying. The last function as well, we are not multiplying, but the intermediate function from x1 x2 will multiply alternatively by 4 2 4 2 and so on. So let's evaluate that integral and see. So keeping in mind our first function f of x naught is 0, and we're not multiplying 0 by any value. So f of x1 we had 0.4163, f of x2 we have 0.9388. So all we are doing now is f of x naught, we are not multiplying by any value, it is 0. Then we multiply f of x1 by 4, plus multiply f of x2 by 2, plus multiply f of x3 by 4, plus multiply f of x4 by 2, and so on to the last value. So that means the integral from 0 to 1.2 of 2x exponential x squared, the x is now going to be equal to h, interval is giving us 0.2 all over 3. Remember, it is in minutes. Now, we are multiplying by the first function, f of x naught. We don't multiply by any value. The result gave us 0 plus 4 times f of x1. And we obtained f of x1 earlier as 0.4163. So you have times 0.4163 plus f of x2 or 2f of x2. So now we multiply by 2, and f of x2, we obtain the value earlier to be this, which is 0.9388. So plus 2 times 0.9388 plus, now we multiply by 4. So we multiply f of x3 by 4, and f of x3 simply gave us 0.7200. So multiply, this is now going to be plus 4 multiply 0.72 approximately, same as 0.7200. Okay, plus after 4, now we multiply f of x5 by 2. So it becomes plus 2 times f of x5 itself simply gave us this, which is 3.0344. Okay, so this is now f of x4. Now we multiply f of x5 by 4. So again, plus 4 multiply f of x5, and f of x5 simply gave us this 5.4366. So you have 5.4366 plus, now the last value, which is f of x6, is unmultiplied by any number. So you simply keep it like this, which is 10.1297. That's 10.1297. And you keep it like that. So you observe the very first function is unmultiplied by any number. The last function we also don't multiply by any number. Then we alternate the in-between functions by 4, 2, 4, 2, 4, and so on. Okay, so this result now simply gives us the value of the velocity. So let's find the approximate value and see. So V is now equal to, we can simply find 0.2 divided by 3 from here, 0.2 divided by 3. This gives us approximately 0.0667. So 0.2 divided by 3 gives us 0.0667 approximately. Multiplying by, of course, 0 is off. Now we find 4 times 0.4163. So we find 4 times 0.4163. That gives us 1.6652. So you have 1.6652. Okay, plus now we find 2 times 0.9388. So you have 2 times 0.9388. That simply gives us 1.8776. We have 1.8776. Okay, next we find plus. Next we find 4 times 0.72. So we have 4 times 0.72. That gives us approximately 2.88. So you have plus 2.88 plus. Next we find 2 times 3.0344. So we have 2 times 3.0344. That gives us 6.0688. So we have plus 6.0688 plus. Next we'll find 4 times 5.4366. So that simply gives us 21.7464. You have 21.7464. And finally, okay, we'll pull down plus 10.1297. So finally, we'll pull down plus 10.1297. And you have this. All right, so the velocity V is now going to be, we have 0.0667 now multiplying. So let's add everything we have here. So we have 1.6652, 1.6652 plus, we have 1.8776 plus 2.88 plus 6.0688 plus 21.7464 plus 10.1297. So if we add all of this together, we simply have 44.37367. We have 44.367. So this will actually give us the approximate value of the velocity to be. So multiply now by 0.0667. That simply gives us approximately 2.96 kilometer per minute. Okay, so if you want to convert this to meter per seconds, you can as well go ahead to convert it, but I am keeping it in kilometer per minute. So this becomes the approximate value of that velocity using Simpson's 1/3 rule. Now, the second part of the question says, if the time is now fixed at t equals 1.2 minutes, estimate the approximation of the distance covered for the first 1.2 minutes. So now we have to find the distance covered for the first 1.2 minutes. Now, when t equals 1.2 minutes, you're being told to find the distance covered. Now, you know that, so recall, you know that velocity is actually distance divided by time. This gives us velocity. So which means from here, you can make distance subject. It becomes what? Velocity times time. So it means that the distance covered is going to be equal to the velocity which we obtained so far multiplied by the time. And we obtain our velocity to be 2.96 kilometer per minute. Now multiply by the time given there is 1.2 minutes, right? So minutes cancels minutes. So I am simply left with 2.96 multiplies 1.2 kilometer. So this simply gives us the distance covered. So distance covered becomes 2.96 multiplies 1.2, which is invariably, which is approximately 3.552 kilometer. So this becomes the distance covered. Now the final part of the question says, approximate the value of G if the closed form solution of the distance covered is given as x equals 4.99 G. So when S is equal to 4.99 G, we are asked to find the value of G. Very simple. From here, you simply make G subject of the formula. That becomes S all over 4.99. So this is going to be equal to x being the distance is 3.552 kilometer. So you have 3.552 kilometer divided by 4.99. So this simply implies that G is going to be equal to, so let's obtain divided by 4.99. So let's obtain 3.552 divides 4.99. That simply gives us 0.7118. So we have 0.7118. So this is the value of G. All right, guys, so that's how to employ the Simpson's 1 all over 3 rule to solving numerical integration problems. I hope you find this video very interesting and helpful. Please, if you do, I would like to get your thoughts in the comment section. Do well to like the video, comment nicely, share to your friends, and subscribe if you're new to the channel, and also turn on your notification bell so you keep getting updates when our next videos drop. For more videos on numerical methods, do well to look at the playlist at the end of your screen. I will see you in the next video. Thanks.